Now, we have to, this is my prediction. Please open your book, please. Page number 213. Mark this important, right? And it is about infinity, right? See, we have seen that ores are the rocks from which the the metals are extracted profitably. We can tell another definition. Ores are metal bearing rocks from which the metals are extracted profitably, right? Isn't it? Ores can be of two types, we'll be learning, right? Ores can be high grade ores, ores can be low grade ores, right? Isn't it? When you see high grade ores, right? High grade ores are what? High grade ores are those ores which will be having a higher percentage of the metals. And low grade ores are there which will be having much less, much less percentage of the metals, right? So it is not economically viable to extract from the low grade ores, right? Because the industrialists, they have to build the quarters to for the workers to stay, build the colleges, build the schools, build the offices, right? Build the roads, right? It needs huge amount of investment, right? So all of the industrialists, mining industrialists, they use high grade ores, all of them, right? Because it contains more amount of percentage of that metal, right? Isn't it? This bit, right? Now do what? This ore is a non-renewable resource, right? It's got a fixed amount of resource, right? Isn't it? Finite resource. So can we think of our future generation to keep some high grade ores from them and so that they can use? Yes. We, for the sustainability aspect, right? We have to use the low grade ores, right? Although low grade ores are very less percentage of the metals which are there, right? Now, in your GCSE, we have got a case study of copper metal extraction of the low grade ores, right? We don't have others, right? We don't have others. We don't have iron and all. We've got a case study. It's a case study by which we are trying to find out that how to use the low grade ores of copper and get the metal, right? Now remember one thing, guys, over here. The two processes which we use are phytomining, underline this part, and bioleaching, right? Now, phytomining and bioleaching, right? These two processes, they are used to extract the copper from the low grade ores, right? Both the processes, what we do, we take the copper iron solution in some stage. You can write down this. We get the copper iron solution, right? This copper iron solution is also called as leachate, right? This part I'm telling you, right? Copper iron solution will be obtained from phytomining or bioleaching, right? We get the copper iron solution, right? This is called the leachate. The copper iron solution, right? Isn't it? This will be reacted with H2SO4, right? Isn't it? To give you what? Copper sulfate. You can write down this step is the same for both phytomining and bioleaching, right? This process I'm writing, right? Somehow we get the copper iron solution. We add H2SO4 and we get the copper sulfate, right? Isn't it? We get the copper sulfate. Now, copper sulfate, we do what next? Next, we are adding scrap iron, right? Scrap iron, not pure iron, scrap iron to lower down the cost, right? So Fe plus copper sulfate gives you FeSO4 plus copper, right? We get this, right? See, displacement reaction occurs, right? Iron displaces copper. Why? Because iron is more reactive. So we are getting FeSO4 plus copper. Now, after we get this copper, right? We do what? Copper is used where? Guys, can you tell me? Copper is used in the
Wires,
wires. In what kind of wires? Very good answer. Where? Which
electrical
wires?
wires.
Electrical wires, and more importantly, where? In the, very good. Electrical wires. More importantly, it is used as fine wires in the electronic industry, right? In the motherboards, right? In the motherboards, right? Fine. So what I want to tell you from this data is that you need 99.99% pure copper, right? The copper purity should be there, right? Is it clear, everybody? Both phytomining and bioleaching will be using copper sulfate solution, copper ion solution. We add sulfuric acid to convert it to copper sulfate. Copper sulfate will be added scrap iron, right? This process is the same. We get FeSO4 plus copper, right? This copper we have to purify by electrolysis. Is it clear? Finally, because this is mainly used as wires, as he brilliantly said, and mainly we are using in the electronic industry, right? In the motherboards, right? Got me? Everybody is clear now. In the phytomining, see, phytomining and bioleaching both are the same, right? Both this process is the same, right? In the phytomining, what happens? In the phytomining, you'll be seeing that we grow we grow plants in the low grade ore soil, right? We got plants. Slowly, with months and years, what happens? The copper 2 plus ion from the low grade ore soil, they'll be getting deposited in the plants, right? Is it clear, everybody? They're depositing the plants. After this, we are doing what? After this, we are cutting down the plants, right? We're cutting down the plants. After many years, we're cutting down the plants, right? And what we're doing? We are burning it. Please try to note down this, right? E to the power infinity, this, right? We are burning the plants, right? When we burn the plants, we convert to the ash. The copper ions is there, see, right? In the ash. What we do? We take the copper ion ash, right? We take the copper ion ash, right? And we dissolve it, right? We dissolve it in H2SO4, right? Is it clear? So copper ions is then taken the ash and dissolved in sulfuric acid. See, this stage we read, right? See, this stage, right? Copper ion solution is dissolved in H2SO4, right? Clear, everybody? This process is the same. And after that, what we are doing? We are taking scrap iron to displace copper from copper sulfate, right? And finally, we are taking the copper which is coming out and we are doing electrolysis. Now, this process is called as phytomining. In bioleaching, what happens? Please open your book and write over here this. Write down over here m to the power infinity. As I have written in your graphite part earlier, m to the power infinity. Memorize to the power infinity. In bioleaching, what we do in bioleaching, we are taking the copper sulfate solution. Understood? After adding H to the 4, we get the copper sulfate solution, right? Isn't it? Sorry. My bad. We are taking the copper low grade copper ores and grinding it. The low grade copper ores we are adding to the solution. We are adding bacteria to it, right? We are adding bacteria. This line you have to memorize by a combination of the biological and chemical processes, right? You have to memorize this. A solution of copper ions is formed, right? In the copper ion solution, see, we get this, right? Got it? We feed bacteria by a process of complex biological and chemical process. The copper ion solution we are getting. This is called a leachate. Then same step, we add H2SO4, we get copper sulfate. Then we are adding what? We are adding iron. The iron will be displacing this copper sulfate copper, right? We are getting FeSO4 plus copper, right? Is it? And finally, this copper is purified by electrolysis process, right? So this is a very important portion we have to master over here, right? Isn't it?